Okay, this is day 2. I'm so glad you guys are here. We're excited about what we're going to be doing today. We have lots of great keynotes and speakers, but the first person is going to kick it off. I have a little anecdote. So my very first week on the job, I get a call from this guy, and his first thoughts to me were, hey, Corey, congratulations. I've got some things you need to improve. Kushagra Vaid with Microsoft.
Hello, everyone. It's great to be here. I was here up on stage last year, and this year there's more momentum around OCP. The number of attendees keeps growing. There's more announcements, new companies joining. The community keeps growing and expanding. That's great to see. So I'm very excited to be here today. Let's go through some of the new announcements Microsoft is making today, and some of the ecosystem growth that we are seeing around OCP. So we'll talk about that. So back in January 2014, which is just a little over a year ago, Microsoft joined OCP, which came as a surprise to a lot of people. Like Frank said on stage yesterday, a lot of people thought, what's Microsoft doing up here? What is Microsoft's intent to join? Anyway, so we joined OCP. We contributed what we call the Open Cloud Server. This is the entire server design that we deploy in our cloud data centers. And we contributed all the engineering collateral for that. The schematics, the Allegro files, the CAD files, the open source software. It was a big contribution, one of the biggest contributions ever seen in the OCP project. And that kicked off our engagement with OCP. The design was a 12U chassis that you see on the visual up there. And it could take up to 24 blades. It had shared power, shared cooling, shared management. And it was a big step forward in how to design cloud-scale servers. We followed up in October of last year. This was back at the European OCP Summit, which was held in Paris. So we followed up with the second contribution. This was another big contribution, where we had the next generation blade that we contributed to OCP. The blade had new features. It supported the latest Intel CPU, the Intel Xeon 2600 V3. We added a slot for accelerator expansion, so you could do crypto, you could do FPGAs, you could do other things using that slot. We also added support for high bandwidth networking, 40 gigabit high bandwidth networking with support for RDMA, routable RDMA, which is also known as Rocky V2. The other cool thing we announced back then was support for M.2 PCIe SSDs. So these are like a gumstick size SSDs, PCI Express, so they're high bandwidth, low latency. In addition, we made sure that these were low cost as well. So you could use commodity NAND flash in that form factor and still use it in a cloud environment. So this was a big step forward. Looking back over the last year since we joined, there's been, in addition to all the specifications, Microsoft has been participating in all the committees. We have several folks involved in all the various committees, 6 committees. And I think in a total, the OCP Foundation recognized that Microsoft had contributed over 4,000 hours of human engagement sort of by participating in the committees and so on. So we are glad to be part of this community. We are glad to be working with the community to advance the state of the art. And today, we're going to announce some additional contributions that will move the ball forward. Before we get into that, let me talk a little bit about the scale at which we are deploying this specification that we have contributed. So OCS is the specification that powers all our cloud data centers. So if you think about the big services that Microsoft operates, Azure, which is the Microsoft's cloud solution, Bing, which is internet search, Xbox Live, which is gaming, Office 365, which is for productivity and collaboration. Different kinds of applications, different workloads, they all run on this common architecture, which is OCS, and they operate across a global set of data centers across the world. So the specification is diverse enough to accommodate various workloads, and it's accessible to anybody now through OCP. So Okay, so let's talk about the innovation that we are driving in OCP. So what I want to show to you today, and we'll spend quite a bit of time talking about this, is what we call local energy storage. What I have here is the power supply with a built-in battery. This is the power supply that goes in the OCS chassis. It's fully compatible with the OCS V2 chassis that we announced back in October. And this is the battery pack that is embedded inside this power supply. So the combination of these two, what allows us to completely reinvent the power electrical system in the data center. And we'll spend quite a bit of time talking about that. The batteries, as I mentioned, are fully integrated into the servers. And what that allows you to do is it allows you to completely eliminate the big UPS battery rooms that are present in typical data centers. So there's significant operational savings, cost savings, build and maintenance related savings that come with that. I'm happy to announce that all the engineering collateral for the LES design is being contributed to OCP. We want to bring the benefits of this design to the broader community so that other companies can also drive down their data center costs. So to understand the impact LES has on our data center designs, let's take a step back and kind of walk through where it fits into the data center, how it changes the equation, and why it's such a big deal. So here's a visual of a traditional data center design. Most of you are probably familiar with how data centers are designed. There's generators in case of power failure. You have UPS systems that take up the load when the power goes out until the generators kick on. Usually, for fail-safe reasons, traditional data center facilities have dual redundant UPSs. So you see two yellow boxes up there, and then that feeds the IT load, the electrical pathway. At the same time, for the cooling system, traditional data centers have usually a chiller-based cooling technique. There's a cooling tower and a chiller plant, and that's a mechanical system to cool the data centers. So the first thing we did, and this is about 5 years back, was we said, okay, let's start to take advantages of new technologies in the data center space and drive costs down. So about 5 years back, we said, okay, let's get rid of the chillers and coolers and go to an adiabatic-based design. So in the visual, you see a big chunk of the data center was eliminated because we didn't need that infrastructure anymore. And in place of that, essentially we had adiabatic airside economizers. So this is done about 5 years ago. But then we started looking at the rest of the data center and said, okay, so where else can we drive cost savings? Where can we drive simplicity? And the big area which was a problem was the UPSs. So the challenge with the big UPSs is, as I mentioned, they're based on lead-acid batteries, and there's a significant cost to maintaining and operating those. We'll talk about that a little more in detail in the rest of the talk. But what we did was we got rid of those UPSs, and you see the yellow boxes inside the IT load, which is the power supply I just showed you with a built-in battery. So you see visually how simplified the data center is now. There's no, the cooling structure is really simplified, the electrical system is really simplified, and the batteries move inside the IT load. So to talk more about this, let me call on stage the person who invented this system, a colleague and friend, Sean Harris from Microsoft.
Thank you.
Welcome, Sean.
Hey.
So I thought we were going to talk about LES, but what do you have that in your hands?
I thought I'd bring a few pieces. I got a battery component here, and, well, you know a drill. This is the cornerstone of how we're achieving cost performance. Hand tools, battery-powered hand tools are taking off in the marketplace. Most every home has a lithium-ion battery cell power tool. Inside this cell is lithium-ion batteries. Batteries much like this cell here. This is a Panasonic 18650 cell. It's a little bit bigger than a AA battery, much more powerful, much better suited to our application needs. This cell is a commodity price or a commodity product, so it carries UL certification. So it's been abused and it has high quality and durability.
That's great. So that's the industry standard commodities.
Yes, it is.
But how does this relate to the LES that we just announced? So let's talk about that. So we mentioned that by installing LES, you can drive up to 5x reduction in the
Yes.
UPS power cost. So how does this battery technology, which is already commodity, help us to achieve that goal?
Well, as you pointed out in the previous slide, scale forces simplicity. We must have simplicity in order to keep our operational cost low. When we look at traditional UPS systems, they're large, high current, high power, lead acid battery systems. They're expensive to maintain. You have to have parallel systems for fault conditions. We have found that they are complex and expensive. We invested R&D time. We evaluated the electrical system from the blade out to the generator, out to the electrical grid, and we have developed a novel, simple solution that provides the functionality.
That's very interesting. Tell us more about it. What is novel in this design?
Okay, in every server you find in the marketplace, there's a switch mode power supply. There are certain circuits you find in that power supply, and we actually insert and embed the batteries in that power train, reusing those circuits. We don't have to buy new circuits or add more components. So we're really getting to an extreme low cost point. And this battery cell, made by Panasonic, I believe they produced over 100 million of these last year. So these are an extreme low cost point volume product. We get a lot of benefit from high volume. When you fuse those two pieces together, a low cost battery and an integrated topology, we're really able to get to that 5x cost reduction.
Okay, so the innovation is really the simplicity of the design,
Yes.
the reuse of existing technologies, how we use commodity technologies and
Yes.
integrate those,
Yes.
and drive simplicity, because at scale, simplicity is key.
That's
to
right.
ensure operational agility.
Right.
Okay, what about the PUE? So we have stated PUE goes down percentage-wise 15%.
Yes,
How does that
we've calculated a 15% number. When you look at a centralized UPS system, this generally has a double conversion stage, AC to DC, and DC to AC. It also has overhead power consumption because it is a large, complex system. And then it has a battery recharge profile, up to 8% just to recharge the batteries. So with the efficiencies and the battery recharge, comparing it to the less, because we're embedding the power or the batteries inside the powertrain, it is a near 99.9% efficient, and we only need 2% battery overhead. You compare those numbers, that yields a 15% PUE improvement.
Yeah, that makes sense. So essentially from the path of the electricals coming into the data center all the way to the IT load, we have minimized the number of conversions.
Yes.
And the UPS was one of the big ones, and that's gone.
Yes, we completely have removed the equipment from all of our facilities.
Right. And in addition, the batteries being in the power supply are not in the path of driving
Right.
conversion losses as well.
Right, because we actually put them in parallel to the bulk capacitance within the power supply.
Right.
I can go into more detail if you like.
No, I think that's
Okay,
good for
okay.
today. So let's talk about the facility footprint. So you've stated its facility footprint can be eliminated by
Yes.
24%. Now that's a big number. I've talked to several people yesterday, and they asked me, 24% sounds like, it's like 3/4 of the data center is left and 1/4 is gone.
Yes.
Why is it so big?
Well, when you look at a typical 25 megawatt data center, approximately 25% of that total footprint is dedicated to housing the flooded lead acid batteries and housing the electrical equipment of the UPS system. We do that for safety and containment reasons. 25%. Now these facilities are 12 football fields in size. Reducing that footprint by 25% avoids 150,000 square feet of build out. No concrete, no walls, no HVAC. And if you look at standard building practices, $220 a square foot, that's more than $30 million cost savings per facility.
Wait, let me get, did you say $30 million in
There-
cost savings per facility?
30 million per facility. As a matter of fact, in all of our data centers going forward, we don't build out these rooms. We have changed the architecture of our data center, and we have saved hundreds of millions of dollars so far.
Oh, that's pretty cool.
Yeah.
So what about the service model? How is it compared to the traditional model in terms of servicing the batteries, maintaining it, operating it? Is that a challenge?
No, not in this case. With less, it is a much more simple action. Here, let me grab the unit. So if you walk into a lead-acid battery room, it has large racks, cables, safety equipment. You need trained personnel to go in, chemical suits, chemical protocols. The same thing goes on with the UPS gear. You got to bring out trained technicians. It may take hours or even days to make repairs on that unit. Whereas with this integrated design, it is simple as walking up, grabbing the unit, pulling it out, putting a new unit in. So
just plug and play.
Plug and play. You're
just
talking
like any other power supply.
You're talking minutes of repair. So we have a couple things going on here. One is that we have a fail small scenario. So when we have a failure, it's limited to one system, and we have a redundant system. So it really doesn't affect the system, but we have a higher reliability. We have a higher reliability because we have a simple design. We have reduced the overall parts count, drives up reliability. We have a reduced mean time to repair. Those two factors drive up our availability.
Yep. Yeah. So with a smaller failure domain, if there is a failure, it doesn't affect a larger chunk of servers.
Right.
It only affects a local chunk.
That's right.
Which means more uptime, we meet customer SLAs even better.
That's right. Now that's the comparison of a centralized. If you have a fault there, it affects the entire fleet.
Go out.
If you have a fault here, it affects only that system, and that system continues to operate.
So all this is great technology, and we are very happy to be contributing this to OCP. Where is this technology going in the future? What's coming next?
Well, I'm really excited about this part. By putting the controls of the UPS inside the server, we have an incredibly quick, low latency reaction system. From detection to action, we can do extraordinary things. And we're just now exploring those areas, but we can do things like peak shaving, trough charging, power capping, storage of RAM, all kinds of things. And our firmware teams are working on many new features that are coming. So I'm really excited about this product.
So by integrating the power system into the IT management system, you can start to enable interactions with the workload, with the scheduling, with power capping. So that's a whole new area that's not been explored yet.
Yes.
But we can start to drive innovation there.
We've never had the opportunity to do this before, so it's uncharted territory. It's a new architecture scheme, and we're just not fully developed there. There's many more good things to come.
Right, and by making it part of the OCP community, we can have the OCP community contribute to driving those new scenarios as well in an open source manner.
Absolutely.
That's great. Thank you, Sean. Thank you for your time.
So if you want to see a demo of the unit, please stop by booth 2. John Sigler will be doing demos of how the system operates, some of the features, and I need to take my toys. Is that okay?
Right.
Okay, thank you.
Okay, thank you, Sean. Okay, let's talk about the other contributions that Microsoft is making for this summit. So the second announcement we made was regarding what we call the switch abstraction interface. So to understand what this is, it would be helpful to take a step back. So traditional network switches have been mostly monolithic in design. And if you've been following the advancements happening in OCP in the networking committee, there's been several initiatives to start to disaggregate the network stack. There's ONI, there is different OSs that are available. However, there's one problem that was still remaining, which is regarding how do you make it simple to have a consistent interface between the network ASIC, which is what drives all the networking protocols, and the software stack on top. So the typical problem here is you have a different OS. The OS interface to the networking ASIC has to be rewritten every time you switch out suppliers or vendors. Now, when you're operating in a cloud environment, you have multiple vendors, multiple ASIC suppliers, and you don't want to have to do kind of re-engineering every time you go buy a new switch. So the question was, how do we start to abstract the networking ASIC interface to drive consistency, simplicity in that interface, which would allow us to focus more of our time on developing applications that integrate well with the cloud network, essentially driving SDN faster. So that's where switch abstraction interface comes in, and it helps drive an open network ecosystem in addition to all the other great efforts that are happening in OCP. This is an effort that's been done jointly between Mellanox, Broadcom, Dell, and Microsoft. And there was a demo that was shown yesterday in the engineering workshop, and I think on the show floor there's a couple demos that are being shown, where you see how the simple interface can allow you to have a consistent mechanism to port your OS using a standardized API to different network switch providers. So it's all in the spirit of OCP's disaggregated network switch and helps drive that open switch ecosystem. So we are happy to be announcing this as well to OCP. This is an open project. It's the source code for this is on GitHub. And if you're on the networking mailing list, there's a lot of activity happening on this front to define the protocols and to continue evolving this interface. So this is something we are very happy to also announce today. Moving on, in addition to the innovative features that we announced, we are also happy to announce partnerships with our ecosystem providers to further advance the OCP ecosystem. Yesterday, when Mark Shuttleworth was on stage giving his keynote, he talked about the partnership that we have with Canonical now, in addition to other partnerships we have. So Canonical's product, which is called Metal as a Service, and which is for bare metal provisioning, and Juju, which is for application lifecycle management. Both of these are now supported on Open Cloud Server, OCS. So what this means is that you can take the bare metal hardware, OCS, from one of the many suppliers who provide OCS. You can get Canonical's software stack and get bare metal provisioning done through that. You can install a variety of OSs, Windows, Ubuntu, CentOS, SUSE, and there's a whole bunch of other different OSs that Canonical supports. You can have mix and match. You can install your OS, your favorite OS of choice. And on top of that, you can also start to have a simplified interface for application management. The same model can also be done inside of Azure. So this drives the consistency between how you can manage your servers using Canonical's software stack in your private cloud data centers and use the same in your public cloud environments also. I should point out that this is, to our knowledge, the first ever solution available within OCP for completely automated workload deployments and provisioning. So that's something that is also available now to the community by virtue of this partnership with Canonical and Microsoft. For the ecosystem, that continues to grow. We have seen tremendous adoption from the rest of the industry for providing OCS-based solutions to the rest of the industry and the community. From the announcements we made back in Paris, there's quite a few new solution providers who are now also supporting the OCS design for availability. On the software side, as I mentioned earlier, we now, in addition to the Windows stack, you also have the Linux stack, thanks to Canonical. And we have also made quite a few gains on the standard side. I talked about the switch abstraction interface, which is a standard that's being driven by OCP itself. Redfish is a specification for an agile web-based implementation for server manageability. I think of it as the evolution of the server management standard. It's been driven by an industry consortium under DMTF. And we are showing demos today where the Redfish specification has been implemented on OCS. So you can now have industry standard implementations that are being driven by other forums, such as DMTF, also implemented on the same infrastructure. So all in all, it shows great community outreach. It shows how everybody's working together to further advance the industry in these initiatives. All in all, the vision that Microsoft has is to drive consistency between the public cloud and the private cloud. Our goal has been to take the learnings that we have from our public cloud by operating large services such as being in Azure across a global fleet of data centers, and taking those learnings and bringing them into the IT environment so that private enterprises, private clouds and enterprises can also take advantage of those benefits. So that cross-pollination helps us to ensure a common platform between the two cloud environments and helps us to drive common technologies between these two environments, which is good for the industry at large and helps to accelerate the growth of cloud computing, which is what we would like to see. So if you want to learn more, there's a Microsoft booth is B2. There's quite a few demos on display there. We have there's OCS V2 chassis and the LES. And Sean and John are there. They can talk to you about that in much more detail than what we discussed here. There's a demo for the Canonical Mass and Juju. There's a live demo for showing how that bare metal provisioning works, so you can go see that. There's a demo showing Redfish being implemented on these servers. The operations toolkit, this is something we announced back in Paris. Essentially, the problem statement was, so people say, okay, I have this hardware, I've installed it in my data center. Now, how do I operate it? How do I manage it? So we had open sourced what we call the OCS operations toolkit back in October last year, which is a set of scripting tools so that any data center operator can diagnose problems, debug problems, find out what's broken, how do you fix it, how do you repair it. So that whole toolkit for data center operators, that was open source. So there's a demo of that also in the booth. We also introduced SSD specification. This is building upon the Paris contribution last time. This is the M.2 SSDs I mentioned earlier. So we have a demo of that as well. So in case you want to learn more about these, I would encourage you to go to the booth and learn more. There's another talk at 12:40 today where Sanjeev Khanna will talk about the OCP ecosystem and how that's driving choices for IT customers. And the technical workshops, I think most of them were on Monday and yesterday, but I think there's a few today. So you could attend that as well. All in all, we are very happy to be here and be part of this growing OCP community. We are happy to make all the contributions and hope that these will be beneficial to the broader community at large. And thank you for being here. Thanks.